Hello, welcome to video 4 on the M2 June 2005 for OCR. Let's go straight into it. Here's the question for question 4. Whoops, let's turn the page. So this time we've got some conservation momentum question here. So we have three smooth spheres, A, B and C, equal radius and masses given in the question. And we've got a speed here of 5 meters per second going to the right for particle A, and particle B is stationary. And we also know a final velocity. So whenever we do this, we always do a before and after diagram. So let's interpret all of our information. So here's mass A, which has a mass of m, and it starts to the right at 5 meters per second and ends, do you know what it ends with? We do not. Ends with VA. And then here's particle B, and this has a mass of 2m, and this is stationary, and I believe we were told that this then moves afterwards at a speed of 2, if I remember correctly from the question. Yeah, so that's going to start moving with a speed of 2 meters per second. Okay, and then we can also put in this particle here. We may or may not need it. So C, and this is 3m. So we want to find the coefficient of restitution between A and B. So first thing we're going to do is we know that the coefficient of restitution is going to be the separation speed over the oncoming speed, or approach speed I should say. Should really be the approach speed. Okay, so they separate at the second velocity minus the first velocity. So v2 minus v1 is the speed that they separate at, and their oncoming speed is this one subtract this one, so that's just going to be 5. Okay, so this is going to simplify whilst you put in some values of 2 minus v1 all over 5. Okay, am I definitely not told the other speed? Nope, don't appear to be, so we'll just have to find that. So on the side here, let's use the conservation of momentum. So 5 lots of m plus 0 lots of 2m will equal v a lots of m plus 4m. Okay, so this simplifies to 5m equals VAm plus 4m. So divide 3 by m, we get 5 equals VA plus 4. And I feel like I've made a mistake here somewhere. No, it's all okay. So velocity here is therefore obviously 1. So we can now, 1 meters per second. So I can put this onto my diagram now and substitute. So 2 minus 1 all over 5 and this is a fifth, or 0.2. Okay, no units for coefficient of restitution, it is dimensionless. So that's it for part I. Okay, for part 2, we want to find, in terms of n, the magnitude of the impulse that A exerts on B. Okay, so we want to find the impulse of B, basically. So we can already see that B was not moving at all, and now it's moving with 2 meters per second. So the impulse we're expecting to be this way, because its change of momentum has now gone to the right. So let's have a look at this one. So, beg your pardon. So, the change of momentum, oops, can't see, change of momentum of B, so it's gone from 0, lots of 2m, to 2 lots of 2m. Okay, so clearly it's changed by 4m Newton seconds. Okay, and not much to that one. Okay, for part 3, we are told some extra information here. So, sphere B subsequently collides with sphere C, which is stationary, and as a result of this impact, B and C coalesce. And now we're being asked to show that there will be another collision after this one. So let's go back to our original diagram, and we can add on some further information. So this is stationary. Okay, and then after this collision, both particles will coalesce and have a second speed which we do not know. Okay, so V, B, C. So let's use conservation of momentum. To the right. So 2 lots of 2m, that's particle B. We'll include this, but you don't really need to if you don't want to, plus 0 lots of 3m, which is effectively 0, will equal V, BC, lots of 5m. Okay, so simplifying this a little bit more, so we have 4m equals 5 V, BC, m. So dividing through by m, we have 4 equals 5 VBC. So the velocity of BC will be 4/5 meters per second. Now if we recall back, our good friend particle A is moving at 1 meter per second, going this way. And now these coalesced particles are travelling at 4/5 of a meter per second. So this is going to catch up and collide. So we can say that VBC is less than VA, therefore another collision. Job done. Okay, I hope that was useful, and watch out for the next video. Thank you.